Okay, so here we're going to be looking at the Krebs cycle. And so you can see my mitochondria here on the right, and I've just very much abbreviated what you see up here. We know that this is glycolysis, where glucose is converted into 2 molecules of pyruvate. Glucose starts with 6 carbons. Each molecule of pyruvate has 3 carbons. Pyruvate will then go through the formation of acetyl coenzyme A, step number 2, to produce acetyl coenzyme A. Since we go from pyruvate with 3 carbons to the acetyl group with 2 carbons, here's the first place we see carbon being removed. When carbon is removed from our carbon compound here, we produce a molecule of carbon dioxide. Coenzyme A actually enters the reaction and picks up the acetyl group to form acetyl coenzyme A. So as we're going into the Krebs cycle here, the Krebs cycle is always drawn like a circle like this because the Krebs cycle is a cyclic series of reaction. It can also be called the citric acid cycle, and that's because of one of the intermediates that we find in this step. So I'm just going to show you the basic concept that you want to remember for the Krebs cycle. The products from step number 2, the acetyl groups, are what are actually going to enter the Krebs cycle. So coenzyme A just drops that acetyl group off. Coenzyme A actually does not enter the cycle, so I'm going to draw it being kicked out here, if you will. The Krebs cycle begins with a molecule called oxaloacetic acid or oxaloacetate. And this molecule has 4 carbons. Now, I'm not going to ask you to commit the name of that molecule to memory, but just showing you what happens here. It's going to begin with this compound. It has 4 carbons. That's going to pick up that 2-carbon acetyl group to form a molecule that has 6 carbons over here. So we're moving, this thing is spinning clockwise, if you will. The 6-carbon compound that gets produced as a result of the union between oxaloacetate and the acetyl group is citric acid. Citric acid has 6 carbons. And that is why it can also be called citrate. At any rate, that's why this cycle can also be called the citric acid cycle. So in the process of going from, because what we're going to do, this is a cyclic series of reactions, so that citric acid is going to undergo some rearrangements and some processing to end up back as this 4-carbon molecule again. So that means that we must have to remove 2 carbons, right? If we're going to go from 6 carbons to 4, we have to remove 2. So when we remove 2 carbons, we're going to produce 2 molecules of carbon dioxide. So that's going to be one of our products per turn of the cycle. In addition, whenever we remove those 2 carbons and we do the rearranging involved, we're going to harvest hydrogen. And that's probably the most important activity that's occurring here at the Krebs cycle, is we're getting rid of all of the original carbon atoms that had been associated with glucose here, but we're also going to harvest an enormous amount of hydrogen. So we're going to pull out some hydrogen and we're going to actually reduce 3 molecules of NAD to produce 3 molecules of NADH plus H plus. And we're going to reduce 1 molecule of FAD. This will be the first place we've seen FAD being reduced. So we're going to produce 1 molecule of FADH2. So hydrogen harvesting here and here. We produce one more thing in this cycle, and that is 1 molecule of ATP. So I'm going to go ahead and just draw it over here because I've got more room over here, but at any rate, we will produce 1 molecule of ATP. So that happens each time the Krebs cycle turns. So the Krebs cycle turns once per acetyl group. So if you look back up here, we actually begin with 2 acetyl groups, right? So these acetyl groups will enter 1 at a time, and that will make the Krebs cycle turn 2 times. So again, if we look at the products for the Krebs cycle, these products that I've listed here are for every time that cycle turns once. But we know that per molecule of glucose, the cycle will turn 2 times. The cycle turns 2 times. So if we want total products produced in the Krebs cycle, you have to double these products. So we'll have 4 molecules of carbon dioxide, 6 molecules of NADH plus H plus, 2 molecules of FADH2, and 2 molecules of ATP. So we're not producing a ton of ATP in the Krebs cycle. The most important thing, again, is the hydrogen harvesting that takes place in the reduction of these 2 hydrogen acceptors. So at the end, back over here, the carbon dioxide simply gets exhaled. We removed all of the carbon, so we have no more carbon compounds. So the only thing that's left to feed into our 4th and final step are these hydrogen atoms here. So the electrons associated with the hydrogen are going to enter the 4th and final step, which is our electron transport chain. So the hydrogens associated with FAD and NAD are going to be given to the electron transport chain in the mitochondria to finish the process of aerobic respiration. So you have another video that will describe the electron transport chain to you. So that is, in a nutshell, the Krebs cycle.